We're going to continue our continuous integration story and talk about storage for infrastructure as a service. Now, this is a little different than what we might look at in terms of storage for containers, although actually there are a lot of similarities, but we'll get into that in another vlog in the future. But in the infrastructure as a service space, one of the interesting things is that storage is being looked at as a technology that provides resource, but it's actually fairly well segregated from the infrastructure service middleware. Really, all the infrastructure service middleware is trying to do is potentially create volume, so create storage components out of often distributed storage environments and map those to other resources. And it turns out that that mapping uses a lot of the technology that was already implemented in the storage environment. So iSCSI initiator and target connectivity is very common. Now there are some differences there because often the actual initiator is the underlying system that's doing the storage mapping rather than the virtual machine that's actually getting the storage. But there's nothing that stops the environment from allowing an NFS mount or an iSCSI mount directly into a virtual machine. When we're thinking about this, though, from the perspective of continuous integration, there are two aspects we need to think about. One is storage attachment. How do we emulate the storage that we would use to build out the middleware and the middleware attachment components? So the classic example there is if we use the Cinder project in the OpenStack environment. Cinder providing basically a storage volume mapping. If we use that tool, we still need to have somewhere underlying storage that we can mount and map volumes from. We'll do a little bit of screen sharing in a moment and look at some of the implications in terms of connectivity. But really the question is, where are we putting these volumes? So one approach is to build out a distributed storage system, an NFS service like a NetApp or a NetApp clone, basically NFS on a Linux machine. As an example, we could do Gluster or Ceph or any of the other storage backing technologies that people use in infrastructure services to back our continuous integration environment, build volumes as needed on top of that, and then map them into our infrastructure. We could also build out, as a part of our continuous integration, a full replica of the storage environment. Often, though, that's a very expensive proposition, and we're not usually looking to test the overall system performance. We would do that in a staging or production validation stage. But we do want to have at least the ability to emulate those storage volumes. So we'll look at that in the screencast next, but I just at least wanted to highlight that delta, the fact that continuous integration for storage, unless I'm looking at the underlying storage subsystem itself, often really looks more at how do I emulate enough storage devices to provide the kinds of access technology, an NFS mount so that I have distributed storage, or Gluster or Ceph for that, a Swift environment so that I can talk to a Swift subsystem. If I have those sorts of components, then I can build out the storage system end to end. And that really is what most people, I think, are looking for when they're talking about continuous integration and the storage subsystem itself. Great. So in this case, we're going to be looking at storage. And when we're talking about storage, we're really talking about two different classes of storage. But we're talking about object storage systems, and then we're also talking about distributed storage systems. When we think about our systems of environment, again, we're going to start thinking about this from the perspective of we have some form of physical infrastructure. Just consider a couple of machines, one of which might be our, let's call it an all-in-one system. And this is going to run our controller VMs, our compute test VMs, potentially our network services components, etc. And then we'll have a separate machine, which in this case is our storage machine. And we may have multiple of these as well. In the last segment, we had looked at the fact that, okay, there's a network interface, physical network interface, and we had a couple of different networks that we associated. We had basically a management network. We said this is probably the principal network for our test environment, and that's going to be virtualized in here. And then in our case for storage, we may actually want a separate storage network as well. And so instead of the tenant side network that we had last time, we'll think about a storage network that might also be overlaid on top of this. Again, if we happen to have the capacity of multiple networks, so we could do VLANs out here, then we would actually do that specifically for that storage network. If we don't, then we have an option of either trying to create a tunnel across the green network here, or just overloading the green network, basically moving the storage traffic onto the green network. In modeling storage for infrastructure as a service for continuous integration, often this storage network actually does go away, and we actually just stick with a storage entity that maps over the management network. Again, this comes back to what class of infrastructure do we have available to us? Are we doing this all in a virtualized environment? Are we doing this in an environment that is a replica of the physical resource, or some other model? So if we create another page here and go back to what is the most likely scenario, which would be to have something like Packet or even Amazon or DigitalOcean, or you name it in terms of infrastructure provider. Again, we're going to have multiple storage devices. We'd probably actually also end up with multiple control devices. We'd end up with just the management network as our actual platform model. And the external network here as well. And this would give us access to the internet at large in some fashion. Again, this would be different for Packet than for something like DigitalOcean, but the model's still the same. And off of this, we would have our virtual machines that would be providing all of our network and compute, etc. services. And then over on this side, we have to start thinking about the disks that we would be using. And in reality, we're either going to spin up a set of virtual machines that are going to provide a model for our distributed storage environment. So if I was going to do something like Ceph, I'd want multiple machines. The physical disk, either disk or disks within my storage node, I might actually map them underneath a controller of some nature. So build out either an MD RAID or software RAID environment, or I would just take a disk and create files on top. So basically doing file-based local disks that then get implemented as disks that get mapped into my virtual machines. So now I have a set of storage nodes that let me build out an equivalent Ceph cluster or Gluster cluster or Swift environment, and actually let me model the physical and middleware infrastructure services against storage. Now, I'm never going to be able to use this for performance testing because I'm just not going to get the local performance to do this. But for infrastructure as a service, so something like an OpenStack class service on top, this is a model that you would use for storage. And again, these storage nodes would then be mapped onto the local network, and then storage traffic, I think I was doing that in red, storage traffic would run across that network as if it were tunneled, even though it's not actually even tunneled. That gives us access to these nodes that actually need storage. And that can be storage both from the controller's perspective. That would be for something like Glance, which is images, or Cinder, and on the compute nodes that would get created, that would be direct attached, either distributed storage for virtualization. So if I want to test something like data migration, I actually have to have multiple entities mapped. So my compute nodes would actually have to have a distributed storage, so they would actually end up with NFS mounts, for example, against this backend, or Gluster mounts, or using the Ceph RBD driver to actually mount that storage. So there are lots of different services, but as you can see, the network model is fairly straightforward. The storage model is where it starts to get more complex, but we're just going to model that as virtualized infrastructure on top of these storage devices. So not as complex as the networking model that you might have to get into, just because in the networking space, most of the effort actually happens at the overlay. Basically, trying to figure out how to leverage these network interfaces without impacting both our physical running platform machines, or our virtualized platform machines, and also then the virtualized middleware that we're trying to actually test against. Here, the real complexity happens in the storage case. It happens here within our storage nodes, where we somehow have to map disks where we don't usually have multiple virtual disks available to us, although having that capability in an environment like an OpenStack environment providing the test infrastructure, so running OpenStack on OpenStack, for example, I might be able to create multiple disks and map them. I might have a little bit more flexibility there, but usually I'm using file-based disk volumes as a way of mapping storage into my continuous integration infrastructure. And again, this gives us a way to model at least the middleware pieces, make sure that the software layer here is functional. And that's really the key to the entire concept behind this. If you enjoyed this session, please don't forget to share it with your friends. And hey, go ahead and subscribe to this channel so that you can be updated next time I post the next vlog.